data encryption and security protocols I will be discussing today. The data encryption and security protocols, first of all, this I will discuss. And accordingly, we shall see that today I will be starting another project or next session. Let's see. But because these concepts are also necessary to be discussed, thus I am simply starting it today. But yes, I have to discuss multiple projects, like one project we did in the previous session. Similarly, we shall do more. So when we talk about the data encryption and security protocols, so encryption techniques used in IoT are simply the symmetric encryption is there. So symmetric encryption uses the same key for both the encryptions and decryption of the data. Symmetric means same key is used. And common algorithms related to the symmetric encryption are AES, that is the Advanced Encryption Standard, and DES, that is Data Encryption Standard. So simply the symmetric encryption is the like public key, only one key is there for the encoding and decoding, or you can say the encryption and decryption process. And the advantage is that it is fast and efficient, suitable for the environments with limited computational resources. So in the IoT devices also, most of the time we have limited computing resources, computational resources are less. So that time, if we are using the encryption, like symmetric encryption, then it will be not a big problem. The use case could be like often used for the encrypting of the data stored on IoT devices or in the transit between the devices within the local network. So, storing of the IoT data, it is used for the storing of the IoT data. Then asymmetric is another type. In the encryption techniques, asymmetric actually use two different keys. One is known as the public key, another is used, which is known as the private key. Public key and private key are the two different types of keys which are used here. And I can just show you the like symmetric encryption. So this is good image with the help of which you will be able to understand it in a better manner. Here you can see. So this is like depicting the symmetric encryption. I'll just show it to you here also. Symmetric, asymmetric for both. I will show you the diagrams. That's good to show some diagrammatic representations, no? So I'll show it to you. Asymmetric, asymmetric, same thing. Symmetric, this is like the diagram for the symmetric encryption. You can see here the secret key is same. Okay, sorry, secret symmetric encryption. Secret key is same. So plain text which is going, plain text means the normal data, which is going to be inserted, that will be encrypted with the help of some hash code and all. And the text which is encrypted, that is known as the cipher text. And then it is decrypted. Okay, then it is decrypted on the receiving end. So that is the symmetric encryption. In the case of the asymmetric encryption, we are having two different keys, public key for the encryption and private key for the decryption. RSA, that is the reversed Shamir Edelman. This is one example, widely used asymmetric encryption algorithm actually. And the advantages is simply enhanced security because there are two different keys which are used. Receiver has another key, and like simply for the decryption, the key is used that is different, the encryption key is different. And it is suitable for securing the communication between the IoT devices and the external servers. The use cases could be like simply the commonly used for securing the data transmission over the internet, such as the HTTPS between the IoT devices and the cloud services. And here, this is the image. You can say diagrammatic representation where the public key and secret key are the two different keys. Secret key or the private key is the same thing. Public key is the public key. Two different keys are used. One key is used for the encryption purpose. Another key is used for the decryption purpose. Another one is the end-to-end encryption. This is another technique used in the IoT, that is the E2EE. And simply when you talk about E2EE, so simply it ensures that the data is encrypted on the sender's device and only decrypted on the recipient device. So in the network, you can say when the data is transmitting, it will be preventing the intermediaries for accessing the data. The advantages are simply providing a high level of security, protecting data throughout its entire transmission path. So end-to-end encryption, you must have heard it the WhatsApp also. The end-to-end encryption is present. The E2E encryption, that is E2E encryption. And the use case is simply ideal for protecting sensitive data in the communication between the IoT devices, such as the healthcare and financial application. That is the most widely used IoT applications where the like it is necessary. Then lightweight cryptography is also there, and it is designed specifically for the IoT environments. Why we are discussing this all? Because these are specifically designed for the IoT environment. Lightweight cryptography involve algorithms optimized for the low power and resource constrained devices. Low power and resource constrained devices. So it balances the security between the limited processing power and energy resources. And battery operated IoT devices like sensor, wearables, traditional encryption techniques may be too resource sensitive. But in the case when you are having some small electronic equipments, devices, then simply the next thing which comes into the picture, that is the TSL. There is a second, actually, simply I'm just moving back. Security protocols for protecting the IoT data. Okay, so simply the transport layer. Now this is security protocol for protecting IoT data. I will be also discussing the TCP, ICP and the OSI reference model in the upcoming sessions. So transport layer security, simply having the widely adopted protocol TCP and TLS. Actually, it is transport layer security. This is the TLS. It is applicable on the TCP IP protocols. And the advantage is that ensuring the integrity and the confidentiality of the data during the transmission of the data during transmission, protecting against the eavesdropping and the tampering. So tampering of the data will not be held. And the commonly used secured for the securing, like in the HTTP, the HTTPS is there, that I told you earlier also. HTTPS is HTTP secure, that is the hypertext transfer protocol secure services between for the transmission of the data between the IoT devices, the hardware. Cloud computing services are the cloud. Cloud is simply the virtual thing which is simply not uh, physically present with you. On the server you upload the data, that is the cloud. So security is necessary. Another is security protocol for protecting IoT data, that is secure socket layer, SSL. You must have heard about it in the websites and all. It is very much required. The SSL certification is also there, which is present on the website, that SSL is implemented. So SSL is the predecessor of the TLS, providing similar security features for encrypting the data during the transmission. And the advantages is simply like true largely replaced by TLS. SSL is still used in some legacy system, the legacy systems to secure the IoT communications. For example, like it does not, like SSL is used in older systems where the, you can say, TLS may not be immediately feasible. So in the small you can say projects, SSL, even SSL we are using. Actually SSL is getting used when the web services we are getting at that time on the website, we use the SSL definitely. Then the next one is the IPsec, that is the Internet Protocol Security. IPsec, that is the Internet Protocol. IP stands for Internet Protocol. Sec stands for security. It is like abbreviation, you can say, but this is the name. IPsec is a suite of protocols that secure Internet Protocol, that is the IP communication, by authenticating and encrypting each IP packet in the communication session. So in one session, the protocol, like simply the packets which are getting transmitted will be secured. And the advantage is like it provides the robust security for data transmission over the network. So like VPN, you must have heard, and many people must be using it also. The VPN, that is the virtual private network, to secure data traffic between the IoT devices and the central network. So the IP address gets changed there, mask changed, actually it gets changed with the help of VPN. Then the MQTT that we have already talked about, and in one project which we have discussed, there I used also the MQTT. So message queuing, telemetry transport with TLS and SSL. So MQTT is a lightweight messaging protocol. Actually, messaging does not mean the WhatsApp message or the offline message you are doing. It is actually the one which is actually carrying the data from one place to another. So messaging protocol often used or for the IoT. When combined with the TLS or SSL, it provides secure communication between the devices. And the advantage is that it is ideal for IoT due to its low bandwidth requirements. As I told you, that low bandwidth devices and small projects are very good to work with the MQTT. And it is widely used in the IoT applications that require real-time messaging, such as smart home systems and industrial IoTs. So real-time data is transmitted there, and I have shown you in the temperature monitoring that how the data was updating in every 5 seconds, because I kept the duration 5 seconds. You can keep it 10 seconds, 1 second, 2 seconds, whatever you need. So refresh rate, refresh duration, I have set in that project 5 seconds. So after every 5 seconds, the data was getting refreshed in the project which I discussed previously in the previous project, temperature monitoring simulator, which we created. Now, there we were using MQTT. Then the TLS, that is the datagram transport layer. Again, I will say that transport layer security, transport layer TCP/IP protocol suite, I will be discussing in the last session, you can say. Last means in between, I will discuss the last conceptual session, you can say, when I will be taking, that will be the OSI reference model and TCP/IP. That is very necessary actually. Every time it is getting used. Every time we are talking about those protocols which are there. So that should be discussed. So the TLS is a protocol based on the TLS, but designed to secure datagram based applications like UDP. UDP is the most popular. So user datagram protocol, it is providing security similar to the TLS. So the DTLS is datagram transport layer security, which provides the security exactly the same which is provided in the TLS, but it is optimized for the application that require low latency. So for the low latency, we use the DTLS, used in the IoT applications where speed is critical, such as real-time sensors. Low bandwidth, but speed is necessary. Real-time data is getting checked in smart grid system and all. There the DTLS is used in IoT devices.